Alright folks, Algebra 2, Module 3. We are now going to go with this first part of Module 3 into what we'll call Unit 8 in the first lesson. Going back to basic integer exponents. You should know those from algebra. Should be a nice, quick, easy lesson. So, I want you to go in your note packet. I want you to skip to the middle of page 4 and go right to the remembering the exponent rules. I want to talk about these. So if we take a look at them, the first one, of course, right here is x of a times x to the b. And if you remember, you keep the base and we add the exponents. So the rule is to add the two. So that's a plus b. Then we add a rule here that says, hey, if we go and we raise a power here to another power, that's called the power rule. We actually turn around and we keep the base and we multiply the exponent, so it'll be a times b. This third rule is just an offshoot of that. Obviously, if I have an a that I'm raising on an x and a y, you multiply it on both pieces. So this is x to the a, because it's a really unwritten 1 times a, and a y, 1 times a, is x to y, x to the a, y to the a. Alright. And then back in 9th grade, we talked a bit. Obviously, if we multiplied same bases, we add the exponents. What do you think we do when we divide same bases? Well, if multiplying is to add, dividing obviously is to subtract. So it will be the top minus the bottom exponent, okay? We've already conquered this one again as well this year. Anything to the 0 power we know is 1 real well, especially when we got the negative exponents in it. And a negative exponent can be rewritten as same as 1 over the positive version. So we've addressed all of these anyways. This is all just review. And now we'll take a look at a few little pieces here. So they want you to rewrite each of these following expressions, okay? And how you can deal with it. All you're doing is, we still multiply coefficients times coefficients. So 5 times a negative 3 is a negative 15. And then this one's the first rule. If you're multiplying same bases, x and x, all you do is add the exponents. So 5 plus 2 is 7. Get your answer. Excuse me. And now we're going to go division. Now, before you deal with division here, we actually have to apply this right here. So I would rewrite this problem as 3x to the 5th. And that whole thing is divided by the bottom. Well, I actually have to, for the bottom, you have to actually take 2x. It's really 4 of those. So you got to do 2 to the 4th and x to the 4th. You got to apply it on both. Well, 2 to the 4th is 2 times 2. 4 times 2 is 8 times 2 is 16. So that turns into 16 x to the 4th. Now, unfortunately, our fractions right here, they don't reduce. 3 and 16, they're not going anywhere. So top part is 3. Bottom part is 16. If you want to take a look at this and you expand that, you got 5 x's in the top, 4 in the bottom. You could turn around and go, oh, I got 5 x's and I've got 4 x's in the bottom. This is the long way. And then they start canceling. Cancels, 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 and cancels. Bottom line when you're done is you've got 3x left on the top, 16 in the bottom. Or you could use your rule right here and say, hey, 5 minus 4 is an exponent of 1. That's where we got it. But that's my answer. Okay? Okay, and 2 more to look at in this short video. We're taking a look at this one right here. I've got 3 over this whole bottom. Obviously, we need to apply the bottom piece first. So it's 3 over. And if I apply the negative exponent times this first, we're going to multiply. It's still a power rule. It's x to the negative 6. Now the deal with this is that thing actually is 3 over, and if you remember the last rule, the 6th rule, which on this page we write down below there with the negative, it's actually the 4th rule down here. It's really written as 1 over x to the 6th power. Okay? And then to flip that up, now I got a 3-level fraction, and basically it's the reciprocal. So this is really going to multiply by x to the 6 over 1 in the bottom, and you multiply by x over 6 to the 1 in the top. Down here, all this cancels out, and we get 3x to the 6th power. all over 1, and I don't have to worry about 1. So there's my answer there. So 2 power rules came into here. Well, the power rule came in, and 2 exponent rules is what I meant, and the negative reciprocal one. Taking a look at this one right here, you might want to flip things. Now, I did the flipping on this one this way. Your other way is to take a look and say, hey, if I got a negative exponent like I do here in the top with x to the negative third, isn't that the positive version in the opposite spot? So I could put it as a positive down in the bottom. So maybe you want to do it that way, which isn't a bad thing to do at all. So I actually have then an x to the 4th in the top, and then in the bottom I have an x to the 8th, and now I'm bringing down the x to the 3rd. Well, how do you rewrite that? Well, I've got an x to the 4th over, if I at the bottom I'm multiplying, you keep the base and you add the exponent, so that's x to the 11th. And now the problem turns into the division piece, which is this number 5 down below here. So it's x to the 4th minus 11, which you guys would tell me, hey, Mr. O, that's x to the negative 7. And then the following thing is now we've got to apply the negative rule back to that number 4 there. So flip the whole thing. So it turns out to be 1 over x to the 7th. And we've got our answer. So a lot of things going on there. Negative pieces brought down. We got our multiplication rules, all that good stuff, and division rules and all that. So that's what we've got. We're going to review those still here in class today and practice a few more, and then you'll have some homework ones. Your big thing down below here is I've got another lesson summary of all your rules. There's an extra one in there over what we did, but we've talked about them going through the pieces, and I think this is the only one I didn't add before. Not a big deal. That's just the same thing as taking this one rule right here and applying it on both. If you're going to divide with a power, you got to have the power applied to both the top and the bottom. Okay? All right, finish this off in class. Take it easy.